Hi guys, so I just wanted to take a moment to explain here. So when we're talking about definite integrals here, right, what we're looking for is, like for a, for example, we've used the fundamental theorem of calculus to find out what the area would be underneath the curve. Now the curve is the integrand, which is y equals 2. And if you look down here, okay, I have the graph of y equals 2, right here. Oh, you can't see that very well. Y equals 2 is this blue line right here. And so the integral, we were talking about it as being the area underneath the curve. If the curve is above the x-axis, it's same as the area. So this really is 26 units squared. Now let's see if that makes sense. We're taking the area underneath y equals 2 from -6 to +7. And it appears I do not have -6 on this little graph. Good for me. Okay. Well, you're gonna have to we're gonna have to just imagine here, if you will, that this graph is extended. Oops, my question's mixed up maybe. So let's see, 1, 2, 3, 4, 5, 6 right here. Okay. So if I'm looking at this here and I'm going all the way to +7, I'm looking for the area underneath the curve from here. Now this is a straight line, so we're talking about a big long rectangle, right? And so look at what we've done here. We've added 14 and 12. Where to get 14 and 12 from? Well, if this is -6 to 0, this is a width of 6 and a height of 2, right? That's 12. This is a width of 7 and a height of 2, and that's 14. So this is actually 26 units squared. You could count them if I had everything on there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, okay? And you could actually count them. So that's that one. Now I do want to show you another one here. So B, all right, so check this out, that the area from, so this is 6x minus 7, this green line. From -1 to 5, we would be looking for this, so -1 is here, okay? So there's where it intercepts the graph there. And then all the way over to 5, so 5 would be all the way up to this spot right here, okay? So we're basically, the integral would be this area here, this would be the positive, this would be a negative. So it would be this area here minus this area here. That's what the integral would give us. So if we just do that one real quick, let's see if it matches up. So what's the capital F of x here for 6x minus 7? What does that equal? That's going to be 6 over 2x squared minus 7x. Okay? So evaluated at -1, or no, sorry, let's go to -5 first, right? Or +5, sorry. So that's going to be 3 times 5 squared minus 7 times 5. And evaluated at -1 is going to be 3 times -1 squared minus 7 times -1. Okay? So that's going to be then the difference here. Okay, so f of 5 minus f, capital F of -1 is what I'm looking for, right? That's going to be, that's what this is. That's the value of this right here. And so that's going to end up to be, what is this, 3 times 25, so that's going to be 75 minus, what is that, 75 minus 35. That's what this is. And then this one here is going to be minus, so that's going to be 3 plus 7. So that's going to be 40 minus 10, 30. Looks like that's 30. So now if we take a look at this graph, and if we were to actually, I don't know, can we count here? Is that too insane or what? That's actually kind of tough. 2, 4, 6, 8. Okay, so yeah, it's kind of tough because this is, 2 of these are 1, and then half of this is, so that's 1 unit right there. So if we were to add these all up, what would we get? Would we get 30? So maybe I'll take a moment to do that. All right, so I took the time to count these squares here, and sure enough, we have positive 44 squares up here. And this is negative 14, or 14 squares down here. So it would be a positive area-ish, right? Positive area. and a negative area. So combine those, you get 30. There you go. So concretely, right, the integral hopefully makes sense now. Fundamental theorem of calculus, using antiderivatives of the given function. So here's the given function right here. Antiderivative, and you take into account the limits of integration. Finding these areas, like we've done, you get the value of the definite integral. So this, remember, this is like a positive area. This is like a negative area. Okay. Hope that helps.